Okay. So, let us start with the F0 modeling. So, if you see what kind of information if you F0 is carrying, in many language the pattern temporal change in F0 is phonemic, which is called tonal language. If you see the tone, variation of tone can change the meaning. So, tonal languages, so temporal variation of F0 can change the meaning of the words. Similarly, if I say the trace, main parameter for defining trace is F0. If I say emphasize word, that means if you found that I have increased the F0 there. So, change of F0 define the tone, define whether that words is emphasized or not, and also in case of English, if you see, this is a contrastive trace language. So, it trace depends on the context. So, if I put arbitrary trace in the words, then I can say that my pronunciation of English is not native like. The problem in here also, suppose I am in Bengali on Indian language, most of the Indian languages are bound trace language. That means, the trace is defined at the beginning syllable of every prosodic word, not linguistics word, not in you can say the written word. For every prosodic word beginning, trace is defined. That is why it is called bound trace language, but English is contrastive trace language. So, you can say the F0 is convey the linguistic information also, like the tone, it can be phonemic also. So, that means variation of the tone change the word meaning. Okay. Then F0 is convey the prosodic meaning of the sentence. If I put the trace in different location, the meaning may be changed. Okay. The old man and woman, if I say the old man and woman, the old man and woman, then I say the man is old, but woman is not. But if I say the old man and woman, then man and woman both are old. So, F0 linguistic information is carrying, not only linguistic information, F0 also carry the paralinguistic information and non-linguistic information. Paralinguistic information and non-linguistic information also convey by F0. If it is male speaker, you know, whether I am male or female speaker, that depends on the variation of the F0. If it is male speaker, you know the average F0 cannot goes 200 after 180 hertz, but if it is female speaker, it is started from 200 hertz, it can goes up to 300 hertz. If it is child speech, you can say that it can started as 250 hertz and goes to 350 hertz. Okay. So, age, all kinds of non-linguistic information and paralinguistic information all are carried by F0. Attitude, emotion, and then speaking style, all can be found in F0 modeling. So, if you see, there is a lot of F0 modeling, and you see that these slides are taken from the Fujisaki F0 modeling. So, that is why copyright Fujisaki is given. So, three approaches of description and representation of F0 contour. So, I can what I said in beginning, that for an utterance has an F0 movement. So, there is a F0 movement. So, this movement of the F0 can be modeled by three things. One is called labeling, which is called Toby, stylization and modeling. So, I can model, generate some model which can generate this contour, or I can say I can assign some label. So, it is a rising, then I can say flat, then I can say falling F. So, rising, flat, falling, sharp rising, slow rising, slow falling, sharp falling, all kinds of label I can assign, and I can model that F0 things, that is called Toby model. Okay. Similarly, I can do some stylization, means I can linearly approximate this F0 contour. So, I can say whole F0 contour is nothing but a sum of some linear line. Within this line F0 is fixed. Okay. So, this is called piecewise linear approximation, or I can generate a mathematical model by which, changing the parameter, I can generate this contour, which is called Fujisaki command response model, which we will discuss details. So, whole sentence F0 can be modeled using three models. One is called Toby, stylization and modeling. So, Toby is nothing but a assigning some label on F0, it may be in syllable, it may be let us syllable wise. So, I can say this is rising, this is flat, this is falling, then I can define the pattern of rising, it is sharp rising, it is flat rising. So, those kind of things is used in Toby model. Okay. Then stylization, I can approximate whole F0 contour is some set of linear line or linear segment, then I can say I can model that things, that is called stylization, or I can generate some mathematical model and based on that model has some parameter and I can vary those parameter to generate this F0 contour, that is called generation process, Fujisaki generation process model. So, we will discuss details on generation process model. Okay. So, this is called Fujisaki generation process F0 contour modeling, that if you remember we have said F0 has a two kinds of variation. One is called local variation, another one is called global variation. If you see here, the green line is the global variation and red line are local variation. So, the local variation are called accent and global variation are called phase. So, that is why I call it is command response model, which is controlled by the phase control and action control mechanism. So, one is control the phase command control the phase part, action command control the action part, and there is a baseline. And Fujisaki model, mathematical model is this. So, let us try to derive this mathematical model as per or I can describe this model as per the Fujisaki papers. Okay, this will come later on. So, if you see that what is how these all vocal cords are there, those are the section of vocal cords. So, vocal cords are here there is a vocal cords, and if you remember that vocal cords are closed in one end and open in one end, this is closing and opening, and this is housed on a some muscle, that muscle control the closing and opening. Okay. So, those are the muscle structures. Now, if you see this muscle, the vocal cord housed in a some muscle structure, some bone and then muscle control bone structures where it can move. So, that muscles can move that bone and that can change the tension of the vocal cords, and that create different F0. So, details I will describe that create different F0. So, let us first see stress strain relationship of skeleton muscles, that is already studied and that the relationship is there. So, this is called physical property of skeleton muscle. The muscles which is how the bone which is housed the vocal cords are connected by muscles, or you can say housed by muscles, and those muscles has a property, that property is skeletal muscles properties. Okay. That is already studied. Then physical properties of skeletal muscle, the how it is varies. If you see this first graph, x axis is tension, y axis is incremental tension dt by dx. So, dt by dx is equal to b into t plus a. T is a tension, b and a are constant. So, I can say dt by dx is equal to b into t plus a. Okay, incremental tension dt by dx, that is relationship. Okay, a and b are constant. Then muscle elongation and tension T. So, I can say how much muscle has to be elongated to produce certain tension, that is required. So, that is the relationship. So, the elongation is x and tension is T, and relationship is T is equal to a into e to the power bx minus 1, a into e to the power bx minus 1. So, elongation, if I elongate the muscles, how much tension will be created, that depends on this equation. If I increase incremental tension, dt by dx is equal to b into t plus a. Okay. Now, from there stress and resolution skeletal muscle. So, dt by dx is equal to b into t plus a. Now, if I integrate both sides, so what will get? I will get t is equal to t0, sorry, t is equal. So, if I, so I can say dt by dx is equal to b into t plus a, where t is the tension, or I can say x, instead of x I can put L, L is the length of the vocalix, T is the tension and A is the stiffness at t equal to 0. Okay. Then relationship is dt by dl is equal to b into t plus a. So, b is a constant, a is a stiffness, at a is the stiffness at t equal to 0, and t is the tension, L is the length of the vocalic. Now, if I integrate both sides, what I will get? I get t is equal to t0 plus a by b into e to the power b into L minus L0 minus a by b. Okay. If I integrate both sides, now t is equal to, I can say T0. What is T0? Static tension. What is L0? Static length, and so t is equal to T0. So, at t equal to T0, the L is equal to L0. So, I can say T0 or at static tension is T0. Okay. So, at T0 static tension is T0, then I can say L minus L0, L minus L0 is nothing but a change of length which I can define as x. Okay. So, I can say T0 plus a by b e to the power bx minus a by b. Okay. Now, if a by b is much less than T0, then I can say t is equal to T0 e to the power bx. T0 e to the power bx, which is there in here, which is equation 3. Okay. Now, if it is T0 e to the power bx, then frequency of vibration of elastic membrane F0 is depends on C0 into T by sigma to the power half, where sigma is the density per unit area, density per unit area. This is the relationship between the elastic membrane vibration, Now, if I take log E of F0 is nothing but a log E of C0 into T by sigma to the power half. Okay. Now, I put the value of t, which is t is equal to T0 e to the power bx log E I can say log E C0 T0 by sigma is one term, to the power half is one term, and e to the power bx and log E, that is plus log e to the power bx. So, I can say log E C0 T0 by sigma to the power half plus log E bx. So, I can say log E bx to the power half. So, half will be there. So, it will be half bx. Okay. So, now if you see, I can say C0 T0 by sigma to the power half is nothing but a constant. So, I can say let us it is defined as FB. So, if it is FB, then I can say log of E F0 is nothing but a log of FB plus half of Bx. Okay. So, x is nothing but a L minus L0. Okay. Now, if it is half of Bx, so if x is time dependent, I can write it is xt. So, I can say that f0 contour or log f0 contour when plotted in logarithmic scale as a function of time can be expressed as the sum of constant baseline, this is the constant, and term and time varying term. A time varying term which will be changed and a constant baseline. So, if you see here, this is the baseline, constant baseline FB, and then the time varying term which is half of Bxt. So, how this time varying term is generated? How this time varying term is generated? This time varying term is generated due to the muscle movement or due to the movement when the vocal cord is housed in a muscle cage, or you can say bone cage which is connected by a muscle, and that movement is defined it xt. What kind of movement it is? It is a two kind of movement. One is called rotation around the cricoid joint due to the, so if I just see this is this kind of housing is there. So, there is a two kind of movement, one is rotation, another is translation, rotation and translation. So, if you see in here vocal cords has a two kind of movement, one is translation and that can change the x L minus L0, and one is rotation. So, suppose I have sketched a rope in here, if I this end if I rotate, the tension on the rope will be increases, okay, or if I translate it, then also tension will be increases. So, these two kind of movement increase the tension, and once it is increase the tension, that change the tension, change the F0, that change the F0 contour, that is xt part, time dependent part. So, this kind of rotation and translatory movement it change the fundamental frequency. If you see somebody can say a man is mimicking the female voice, how he does it? Because his vocal cords mass and tension are there. So, once he talk normally his F0 may be in around 100 hertz or 120 hertz, but when in mimicking he can change it to somewhere else, female voice. So, how he does it? By moving this, by practicing this type of movement, rotation and translation movement, he practice it and he can change the F0 to that scale. Anyhow, we can change our F0 movement is there, sa to sa is 1 octave movement is not natural. If my base F0 is 80 hertz, I can change up to 160 hertz, because that is practice when you are singing. When I am singing, what you are doing? We are practicing the movement of the F0. So, you are actually rotation and translation are practiced. How much movement, and this rotation and translation can change the f0, then how this will be used in prosody or how this will be used in continuous movement of the f0 is an important factor. So, how it is used? If you see that rotation is provide a component which is x2t and translation is provide a component x1t. So, total change is x1t plus x2t, which is in log f0 contour. So, this will be additive in log f0 contour. So, x1t and x2t is added and that change the log f0, it is additive. Now, if I say this relation with that language, so if I say the phasing and accentuation. So, there is a local variation and there is a global variation. So, if I say the global variation is phasination and local variation is accentuation, accent, local accent. So, then I can say accent is controlled by rotation of thyroid muscle and phasing is controlled by translation. So, translation mechanism control the global variation. So, translation effect is time, if it is xt. So, translation will change the f0 in roughly change the f0 and rotation will change the local variation. So, global variation plus local variation in logarithmic f0, it is a superposition, but in if it is non-logarithm, then it is a multiplication. So, this superposition. So, they are superimposed with normal f0 with the accent component and phase component. Okay. So, that way we are changing the f0. So, translation and rotation, details are is there. So, you can see this is this kind of system. So, there is a membrane. So, it can rotate if Ct is this is constricted, if this portion is constricted, Ct is constricted, and then I can say it is rotatory movement, and if this portion is strained, then it is a translatory movement. So, if I say this is my membrane, I am not drawing it correctly. So, this is the this is my things. So, if I move it like this way, then it is rotation. So, if I move it this position, then I can say this angle is nothing but a theta. So, this is rotation. Now, if I translate it, then it is L plus x. If I move this direction, then it is L plus x. So, L is the length of the vocalic, x is the extension of elongation of vocalix, theta is the angular displacement of the thyroid. So, if I do the angular displacement, there also be a length change. If I do the translation, there also be a change of length, and that is L minus L0, which is produced by, which is represented by xt, and this xt is summation of these two change in logarithmic domain. One is rotation, another is translation. Okay. And this rotation and translations are nothing but a spring mass movement. So, if it is a spring mass movement, then it is a second order differential equation. If you remember that spring mass movement of a body, mechanical vibration, spring mass movement. If you remember that M, S and R, so you know that d2 m into d2 x by dt square plus r into dx dt plus sx is equal to force, the force which is applied. Okay. So, I can say I x is in term of theta, d2 theta by dt square plus r into d theta by dt k into theta. K is the stiffness, r is the mechanical resistance and I is the mass of the muscle. So, mechanical resistance, mass and stiffness, then I can find out the relationship, the movement variation of theta. So, if I solve this second order equation, so it is nothing but an exponential solution. So, it is nothing but an exponential solution. So, I can say theta t, which can be expressed as a constant multiplied by a exponential curve, which is represented by minima of 1 minus 1 plus beta t e to the power minus beta t or gamma. So, this is experimentally verified and find out by Professor Fujisaki, and he find out the value for beta and gamma for Japanese language, and we have verified it for Bangla language. Then beta and gamma is working fine. Okay. So, if rotation give me the action component, then I can say GAT represent the action component with a multiply by a constant which actually contain the amplitude of that component. So, if I see that the rotation angle theta t is varying like this, elongation will be delayed, then logarithmic f0 also will be like varying like this. So, if you see in action component, so suppose this is the global component in the action component, it will vary like this. So, even if I apply the command in here, it will be take time to reach the up, and again it will be going down because of elasticity. Then again if I apply a command in here, it will be again up somewhere else because it requires some rising time. Okay. So, this is Professor Fujisaki's slide I have taken. Then you can say the translation also same equation, differential equation, and translation is defined by GPT. So, you can say the total equation is like this, where you can say I equal to 1 to capital I. What is this? This capital I is nothing but a number of phrase command. So, suppose I have a sentence, I can say this here. This is the Bengali sentence. If you see, this dotted line are original F0 extracted from the speech. So, this is aligned, actually this F0 contour is aligned with the original speech of Bangla sentence. One Bangla sentence is there. If you see, the Bengali sentence is written. Now, if you see that black dots are original, red one, if you see the red one are generated F0 contour, okay, and blue ones are the phrase command. Blue one is the phrase command, and this action command is created after the phrase command is placed, then the action command is put, this red line is generated. If you see, the red line almost follow the black dot S. So, it is almost possible to model the F0 contour using this phrase command and action command. So, if you see, there is a number of phase. So, here I represent the number of phase. So, I equal to 1 to capital I. So, if there is a 3 phase in here, if you see how many phases are there, 1, 2, 3. So, 3 phases are there, 1, 2, 3 and 4. Last one is negative phase, amplitude is negative. So, it will be negative direction. So, 3 phases are there, 4, 1 to 4. API are the amplitude of the phase command, and this is the variation. Then action command, j equal to 1 to capital J, number of action command. How many number of actions command are there? 1, 2, 3, 4, 5, 6, 7. So, there may be a 7 action command, and this is nothing but action command amplitude. Now, if you see this one, the red line is completely follow the green line, dotted line. So, I can say it is possible to completely generate the original F0 contour using this phrase command and action command. Okay. Today I stop here, this lecture I stop here, and tomorrow I will play this voice sound. So, I arrange this playing of the voice sound. I will show you how close this original speech and synthesized speech. Okay? Thank you.